Assalamu alaikum. Let's discuss another example. Let's assume we have the following block diagram R of Z. Here we have G1 of Z. Here we have G2 of Z. And let's assume this is Y of Z. A feedback with a gain of H of Z is used. Now let G1 of Z is equal to A over Z plus B, and H of Z equal to 1 plus CZ, where A, B, and C are constants. And also, let's assume that this block diagram is represented by the following state space representation: x1 of k plus 1, x2 of k plus 1 is equal to the state matrix, which is 0.5, 1, minus 1, 1, multiplied by x1 of k, x2 of k, plus the input matrix 0, 2, and the input is r of k. The output equation y of k is equal to 1, 0, multiplied by x1 of k, x2 of k. Now we need to find the constants A, B, C, and also we need to find G2 of Z. And given the following info, given that this is x2 of Z, so now we need to find the constant, the A, the B, the C, and we need to find the G2 of Z. So now let's see what information we have. Now, from the state space representation, the first thing we have here that y of k is equal to x1 of k. So simply this means that y is equal to x1 of z. So simply this means that G2 of z is the pulse transfer function as can seen between x2 and x1. So this will be x1 of z over x2 of z. Now let's see from the state space representation also. We have x1 of k plus 1 will equal to 0.5 x1 plus x2. So in Z domain, this will be Z x1 of Z, if we assume that the initial condition is equal to 0, will equal to 0.5 x1 of Z plus x2 of Z. So simply, this can be simplified as Z minus 0.5 x1 is equal to x2. So now from here we can find x1 over x2 to be 1 over Z minus 0.5, which is the G2 of Z. So now we found the G2 of Z from our understanding of the state space representation and the relation between the input and the output in the pulse transfer function. Now from the block diagram, what we have? Now from the block diagram, G1 of Z will equal to, now the output here is x2 of Z, and the input here is R minus HY, and we know that Y is equal to x1. So this will be R minus H x1, and G1 is given here, so this will equal to A over Z plus B. So now let's simplify this one. So this will be x2 Z plus B will equal to A R minus A H x1. Now H here is already given. This is the H, which is 1 plus CZ. So H is equal 1 plus CZ. So now we can write x2 Z plus B is equal to A R minus A, instead of H I will write 1 plus CZ multiplied by x1. Let's simplify it. So this will be Z x2 will equal to minus B x2 plus A R minus A x1 minus A C Z x1. Now Z x1 is this one, so let's substitute this one here. So now we have Z x2 is equal to minus B x2 plus A R minus A x1 minus AC, and instead of Z x1 I will write 0.5 x1 plus x2. Let's collect the terms. So in here z x2 will equal to minus a plus 0.5 ac x1 minus b plus ac x2 plus ar. Now we need equation that represents the x2 z x2 from the state space representation. Now this is the state space representation. So from here we can write x2 of k plus 1 is equal to minus x1 plus x2 plus 2rk. So in z domain, this one in z domain, assume the initial condition is equal to 0. This will equal z x2 equal to minus x1 plus x2 plus 2r. So let's take this one here and compare it with the equation we have here. So now this is from the block diagram. Now from the state space model or representation, we have z x2 is equal to minus x1 plus x2 plus 2r. Now if we compare, a now is equal to 2. So now here a is equal to 2. Now if we compare this one with the coefficient of x2, which is the one here, we can find that minus b plus ac must equal to 1. And finally, if we compare this one here with the coefficient of x1, we can find that a plus 0.5 ac is equal to 1. Now here a is given. Already we have a equal to 2. So from here we can calculate the c. So t 2 plus 0.5 multiplied by 2 is 1. C equal to 1, which implies now C is equal to minus 1. And now we have the A and we have the C. So we can calculate the B. So here B plus AC equal to minus 1, which means that B is equal minus 1 minus AC, and this will equal minus 1 plus 2, which will equal to 1. So now we found all the unknown. C is equal to minus 1, B is equal to 1, and A equal to 2, and G2 was equal 1 over Z minus 0.5.